thing I did was found my derivative. And then by finding my derivative and simplifying it in the whole one, it was f prime of x equals negative x plus 2 all over the square root of 4 minus x plus 2 squared.
Oh wait, the 2's canceled. Except I had x minus 2, not x plus 2.
Okay, well if you just distribute that, you get negative x minus 2.
Oh yeah, I just messed up that one.
You want me to do the first line?
I see that the 2's canceled.
Yep, so you would have 1/2 4 minus x plus 2 squared to the negative 1/2.
Oh, I got that.
Okay, times derivative inside. So derivative of 4 is 0. So negative 2.
X plus 2.
Mm-hmm.
Times 1, so it doesn't matter.
Right. So this 2 and that 2 cancel. The negative from that 2 does not cancel though. That's where my negative right here comes into play.
Oh, I see what I did. I dropped my negative to the top.
So you get negative x minus 2 if you wanted to distribute it in, but you cannot lose that negative.
No, I got that. I wrote the problem down here. I didn't do all that stuff.
Got ya. So the second thing you need to do now is to look for where does f prime equal 0 and where does f prime not exist. So in order to do that, f prime of x equals 0 only when the numerator equals 0. So when would negative x plus 2 equal 0? Not 2, negative 2.
Well, I have 2 because
That's right. Oh, so it's only when the numerator equals 0?
And then f prime of x does not exist when the denominator equals 0, because that would give you your vertical asymptotes. So when the domain comes from the original, but then your zeros come from the numerator and the denominator equaling 0 separately. So this is going to equal 0. If you work backwards to get rid of the square root, you'd square it, then you get 4 minus all of this. So really what I need here is for this to be a positive 4. So I need 2 plus 2. So when x equals 2.
So
0.
Want to do 1.
That'd be 0.
Oh, no, it is, no.
Now, I was going to say, and negative 4, because you could make it negative 4 plus 2 to give you 2. And all of these have to fall into the domain that was given to you, which is negative 4 to 0. So negative 4, 0, and negative 2 all do fit in. So this doesn't exist, right? Because it's not supposed to. It is a vertical asymptote. But it would exist on my original. Because on the original, the square root's in the numerator.
Yeah.
So, like, you have to test point f of 0, f of negative 2, and f of negative 4 all into the original function, as well as the endpoints, but the endpoints ended up being my zeros, so it didn't matter.
Based on this domain, well, I guess it's just by chance because it's negative 1, 0, because it's at the included, so like you could take
Yeah. But if you plug in 0, you get 0. If you plug in negative 2, you get 2. If you plug in negative 4, you get 0. That makes these my absolute mins, and I have 2 of them. And that makes this the absolute max.
So you have to plug back in the original.
Correct. So you have to find your derivative, find the zeros and DNEs of the derivative, and then plug all back into the original,
And the endpoints.
as well as the endpoints. So part B is the same derivative, which means it's the same zeros, but what changed is the interval.
Doesn't matter.
Right, so like part B, it's from -2 to 0 this way. So now that -4 is excluded, the 0 is excluded, but what about having an open and closed interval together happens to my theorem? So if I have an open/closed interval,
Oh, it doesn't apply?
exactly, so this fails the extreme value theorem because it has an open interval. And the extreme value theorem says it has to be a closed interval. So we can't even apply the extreme value theorem because it fails the extreme value theorem because of the open interval on the 0. Okay, and then part C, we have 1 and 3. So I already found my derivative, right?
Yeah.
And I already know where the critical points for my derivative are going to be, and they're not going to be from 1 to 3.
Mm-hmm.
So what I need to do now is really just check 1 and 3.
Yeah.
So if you plug in f of 1, you get the square root of 4 minus 1 plus 2 squared. So 1 plus 2 is 3. 3 squared is 9. 4 minus 9, yeah, is the square root of a negative number. So what does that probably tell me about this interval and the domain of my original function? Yeah, like these points here do not exist in the domain. So where it says in that theorem, it says that f has to be continuous on this interval. Well, if f doesn't exist on this interval, then it cannot be continuous.
No.
So part C also fails EVT because the domain of f is x less than or equal to 0. The highest x value you could actually plug into f was 0.
So
Yes.
basically, after you take the derivative, find the zeros,
Mm-hmm.
and then you want to plug in the endpoints and the zeros to the original.
Correct.
And if they don't exist, then the value is included. Or like if they don't like, it's not continuous, or if it's not.
Right. So like if you have an open interval,
Yeah.
it fails EVT.
Okay.
If your interval isn't continuous, then it fails EVT, meaning that like something in that interval does not exist in the domain. So really EVT says, okay, it has to be closed, it has to be continuous, therefore I am guaranteed an absolute max and an absolute min in that closed interval for the function f, and they could be at an endpoint.
So really for EVT, you're only finding the derivative to get the zeros in the derivative to plug back into it.
Exactly.
How do you know if it's absolute as opposed to local?
So if you had multiple critical points and you plugged all those critical points back into f, the absolute would be your highest and your lowest number, and all the other ones would be locals.
Okay.
So number 2 is also asking the same type of question. So number 2 is saying find the extrema. So you have g of x equals 2x minus 3x to the 2/3 on the interval -1 to 3. So if we think about this function as a whole, this is kind of like saying x squared inside a cube root. So we know that cube roots can be positive or negatives because they're cube roots. So I have no issues with negative numbers on that. And actually, they're all going to be positive anyways because I'm squaring the x. So my domain for this function is pretty much all reals. There's nothing that doesn't work for it. So now let's look at g prime of x. So the derivative of 2x is 2. The derivative of negative 3x to the 2/3 becomes negative 3 times 2/3 times x to the negative 1/3. What's wrong? Right. Because you cancel your 3's. So you get 2 minus 2 over the cube root of x.
Yeah.
And the point of my dropping it down there is because when you find your zeros and your critical numbers, if you want to do what I did in the previous example, which is to set the numerator and the denominators equal to 0 separately, then you must have a common denominator. Which means this needs to be 2 cube roots of x minus 2 all over the cube root of x. So now I can say, okay, when will the numerator equal 0? When will the denominator equal 0? So the denominator's 1 is really easy, right? The cube root of x is going to equal 0 when x equals 0. So g prime of x does not exist when the cube root of x equals 0 or when x equals 0. G prime of x equals 0 when 2 cube roots of x minus 2 equals 0. Yeah, you would simply add your 2 over, divide by 2, not 0. Yeah. So you get the cube root of x equals positive 2 divided by 2, which is 1. So x would equal 1. Now, looking at 0 and looking at 1, are they in my interval?
Yes.
So now what I have to do is I have to go back to the original. So I'm going back to g and I'm plugging in negative 1, 0, 1, and 3. So I plug in the CPs I found, which are guaranteed local mins and maxes. These are guaranteed to be a local min and a local max. What they're not guaranteed to be is the absolutes, because I don't know what's happening to this function. It could be increasing this way, it could be increasing that way. So if you plug in negative 1, you get negative 5. If you plug in 0, you get 0. If you plug in 1, you get negative 1. And if you plug in 3, 3 squared is 9, the cube root of 9 is gross. 2 times 3 is 6, so 6 minus 3 cube roots of 20, or of 9. So it's like 2.23. It's going to be like a tiny little decimal. It's going to be like close to a 4. Somewhere in that zone. Which doesn't matter anyways, because I know right here that negative 5 is going to be more negative than this. And then my highest is going to be at 0. So this right here is the absolute min. And 0, 0 is my absolute max. There will be no point higher on G in that closed interval of negative 1 to 3 when 0, 0. So this is like a small snapshot of this graph.